Welcome to part 2 of this AP Macroeconomics review, and I was looking at a number of the graphs that dominate the study of macroeconomics. As I said in the first video in part 1, there's really more than 7 graphs, and some of these are more important than others, like the aggregate demand, aggregate supply model. You're almost definitely going to need to know. The consumption function, you probably won't have to draw that one, but maybe. Phillips curve, good chance you'll have to draw that one. You should understand where those different points are and how they relate to the aggregate demand, aggregate supply model. But that brings us then to page 2. I got 3 more graphs, and hopefully I can do these a little quicker. And then part 3 of the video, we're going to look at a couple, just at least one scenario, and kind of tie all these graphs together as best we can. So let's pick up where we left off. Our next graph is the loanable funds market. As we stated before, when you make money, you have a marginal propensity to consume. It equals really 1 minus your marginal propensity to save. Wow, novel idea, right? We didn't go into a lot of great detail there, but if you make $1, I could rewrite this, right, as 1 equals the marginal propensity to consume plus your marginal propensity to save. So if you make $1, you're going to consume with some of it and you're going to save with some of it. So it's not a novel idea, but some of that money is going to be saved at a bank or somewhere else, and maybe a money market fund, and you're going to earn some interest on it. Now, that's not incredibly detailed, important detail, so I'm going to erase that out of there. That money that you put in the bank, what do banks do with it? Well, they turn around and lend it. And so the more money you save, and we'll just use bank for a simple example, the more money you save in the bank, the more money there is available to lend. Now, if we're looking at the loanable funds market, what we're really looking at is the real interest rate, which really is the price of your money, isn't it? If you decide, maybe nominal is maybe a better way to say the price of your money, but the interest rate, the money that you could earn on your money, on your savings, would be the price of holding on to your money. If you're borrowing money, the interest rate is a cost to you, so it's the price of borrowing money. So yes, again, we're still using P and Q. In this case, P is the real interest rate, and Q is the, not supply, wrong word, the quantity of loanable funds. I'll just call it quantity of loanable funds. Q of LF. And like all of our other graphs, oh my goodness, we have a demand for loanable funds, and we have a supply of loanable funds. And the graph makes sense if you think about it. At a high interest rate, you would put all, if the banks were paying 20%, you'd put your money, as much money as you could scrounge up, you would put it in the bank. If the bank is paying 0.025%, like I think mine is currently paying on savings accounts, you aren't that inclined to put much money into the savings account. On the flip side, if you want to get a car loan to buy a car, or more often you'll see this loanable funds market talking about businesses investing. They have to buy a new factory or they have to buy new machinery. If interest rates are low, everything else being the same, you're tempted to borrow because it's really cheap to borrow. If interest rates are really high, you probably don't want to borrow some money, and so we end up with, like everything else, we end up with an equilibrium interest rate, and we end up with I should label that equilibrium, and a quantity of loanable funds equilibrium. Now things can adjust the supply and the demand for loanable funds. For instance, if you I don't know, if you expect to get a raise in the future, then your demand for, or sorry, if you expect to get a raise in the future, you're less worried about saving your money. Thus, the supply of loanable funds is going to go down, and that will drive interest rates up. That often happens when the economy is doing really well. If your house value is going up, this was actually really common in 2007, 2008, housing values were really going up. People were less concerned about saving for their retirement because they had this wonderful asset, their house, that was worth a lot, and so maybe they were less inclined to save. So as your wealth goes up, you save a little bit less. Of course, in 2008, the market crashed, housing market plummeted, your wealth plummeted, your certainty of your job plummeted, you got scared, and so you saved a whole lot more, and that would actually drive interest rates down. You guys saw this in your game. When our economy was in a recession and you had the danger of losing your job, you were concerned, and so you were more tempted to save. Of course, that made it hard for the economy to come back out of the recession. All right, last graph. Last graph that talks about interest rates. This time we're talking about nominal. And maybe I should take just a second to distinguish between nominal and real. The real interest rate, how much you actually earn, is the nominal interest rate minus inflation. So if you get 10% interest, but inflation is at 10%, well, you're not really gaining anything, are you? If the nominal interest rate is 10% and your inflation is at 10%, you're not really gaining anything. So the real interest rate is that nominal minus inflation. And so what really determines interest rates that matter is that loanable funds market. But these two are very closely related, especially in the short run. So what changes the nominal interest rate is the total amount of money available. And so this is the quantity of money. So again, PQ, interest rate is a price, Q is your quantity of money in this case. And like everything else, we have a demand for money. At a low interest rate, you are likely to keep your money in cash and keep it in your wallet. There's really no advantage in putting it into a savings account or buying a bond or anything like that, because the interest rates are really low. So people demand a little bit more money. At high interest rates, again, you're going to run to the bank. You're going to try empty your wallet out of any possible cash so that it's in the bank as long as possible. The money supply, though, is what the money supply is. That's controlled by the Fed. Oops, money supply. Let me write that as supply of money. And so that is how much money is going to be available, and you're going to get a, come on, there we go. You're going to get an equilibrium interest rate. If the Fed were to increase the money supply, we'll do that in green. This would be an increase in the money supply, and they could do that through their open market transactions. Again, in this case, I always stop and think about this. I literally put myself in the place of the Fed, and if I want to increase the money supply, well, I'd have to buy something so that I could give somebody some money. So I would buy government securities. So green is buy government securities. When I do that, I effectively drive down I'll call this 2. I effectively drive down the market interest rates by increasing that quantity of money. If I want to shrink the supply of money, I would sell some government securities. When I sell something, they give me money, and I, as the Fed, can turn around and put that in a big old shredder, and then put those shreds of money into a little bag and sell them as gifts in our gift store when people come visit the Fed. No, but seriously, what I would do is I would destroy the money supply, and I would shrink it down. Our last two then, well, I'd say our last two depend. Well, no, these next two depend on the. I'm talking out of my rear. These next two graphs are really two sides of the same thing, the foreign exchange rate. Same as everything, we are going to have demand. We are going to have supply. And we are looking at the quantity of currency A, so that could be like the quantity of US dollars available for exchange. And then we have to talk about the price of currency. So this is when we're trying to exchange our money with a different country, because of course if I want to buy goods that are made in China, I need some Chinese yuan. If I don't have their currency, I can't really buy their goods. So there you go. So if this is the market for US dollars, we'll call currency A market US dollars. This would be the quantity of US dollars, and then we have to think about it as a price, and the price is always in terms of a different currency. So how many currency B would I need per A? And of course what I end up with is an exchange rate equilibrium, and the same thing is true for currency B. If we're going to have a demand and a supply of that currency, and again, if we're going to price it, if we're going to give it a price level, so I got the quantity of B in the market, and I guess I could say I have an equilibrium quantity too. I should probably label that. The price level here is the exchange rate, and again, we always label it in terms of another currency. So how many A do I have to spend per B that I buy? All right, and then what we get is really, again, often two things of the same thing. So I'm going to illustrate just an example here. People in country A are buying more goods from B. Oops. Goods from B. How does that look on these two graphs? That they essentially show the exact same thing here. Well, if people in country A want to buy from country B, then they are going to need to get rid of their currency A, of their A currency. They've got whatever their currency is, they need to get rid of it so they can exchange it for something else. So the supply of currency A is going to increase, which means the price of the value, the exchange rate value of currency A is going to go down. On the flip side, these people from country A are trying to buy more B, which means they need the currency for country B, and so the demand, I should probably draw my little arrows in just to illustrate there. So my demand for the currency B is going to increase, which means the value of currency B is also going to increase relative to A. So A is decreasing relative to B, and B is increasing relative to A. That's two ways of saying the exact same thing there. The important thing about this too that always gets asked is, well, is this good for B or is this good for A? Well, the strong currency. So in this case, country B has a strengthening currency, a strong currency. I'll make sure I'm saying this correctly here. A strong currency, is that good for importers or is that good for exporters? Well, as their currency is getting more and more expensive to buy, it's going to be harder and harder for people who export goods from country B to export them. So a strong currency is bad or hard on exports and is good for imports. So as this happens, as that currency is getting stronger and stronger, well, it's making it easier for people who live in country B and have that currency to be able to buy stuff because their currency is worth more. But it's harder and harder to be able to sell stuff overseas because that currency is getting stronger. Obviously, the reverse is true. A weak currency is good for exports because it's relatively cheap for other people to buy your stuff because they're buying it with your cheap currency, and it's bad for imports because it's hard for you to buy foreign-made stuff if the money you're trying to buy it with is not worth very much. So there you go. I think that brings me down to our last graph, and then we will do an example together. And this is a graph that we also used in microeconomics, and so you're likely to see something similar in a microecon test. If we think about a country, and oftentimes we use this when we're trying to boil down the simplest of possibilities. Like a country could produce just two things. They could produce corn or wheat. And we can use it then to show that with because of comparative advantage, two countries can trade with each other and they can both be better off. They can both get outside of their own production possibilities. But we often also break it down into two simple things, and I'm going to do it this way, as capital goods, so machinery, and consumer goods. So things that we would use up versus buying machinery that will help us produce more in the future. And a country can produce, they could spend all of their time on consumer goods, or they could spend, and they'd get that many, whatever number that is, or they could spend all of their time on capital goods, they could get that many. They could split their time and do half their time on, consumer goods and half their time on capital goods, and bottom line is you're going to get some sort of curve that connects these two. I intentionally haven't drawn this yet as a curve because there's really two different possibilities here. If it's easy to switch from producing consumer goods to capital goods, then you'd end up with this straight line curve. Like, hey, I'm going to produce pizzas for 2 hours and then I'm going to turn around and start building a pizza oven. I often use that as my example in class here. Pizza. This is pizza. This would be the pizza. What am I doing? Pizza oven. Capital goods are like that. Consumer goods are like the pizza. If I can just as easily produce pizza as producing pizza ovens, then we're going to get a straight line production possibilities curve. More realistically, we're probably going to see most production possibilities curves look like that. And what that would imply then is an increasing opportunity cost, right? As I go from going 0 capital goods to 1 capital good, I'm going from here to here, and I'm giving up virtually no consumer goods. But as I try to go from this many capital goods to this many, well, now I'm giving up quite a lot of consumer goods. And so there's an ever increasing opportunity cost that makes that production possibilities curve concave outward. Probably the most important thing to be able to do with this curve, one, you might need to be able to draw it, but then also be able to understand the difference between the concave and the straight, and then also the importance of this related to that principle of comparative advantage, and how if you have a comparative advantage and you specialize in one thing and trade for it, then both countries, both parties can be better off and can actually get to points outside their production possibilities. Last thing that I wanted to point out about this, and this is why I used capital goods and consumer goods, if you produce capital goods or you have some sort of advent of new technology, then you can actually get growth in your economy. But I want to distinguish between the different points on here. If you're at point A, then you are inefficient. This would be equivalent of a recessionary gap. You are not using all of your resources, so you're not using all of your labor, you're not using all of your machinery that you could be using, you're inside that production possibilities. If you are at here, we'll call that point B, you are at your limit. That is that long run equilibrium, that is full employment, and the only way you can get more consumer goods at this point would be by giving up some capital goods, so you can't increase beyond that. To get to point C, one way you can do it would potentially be through trade, but the other way that you have to get to point C is through growth. And what that means is an increase in the long run aggregate supply. You could also refer to that as a outward shift of the PPC, this production possibilities curve. So this is unattainable except through growth. So to get to C, you'd have to have some sort of growth. So if you produced a lot of capital goods, you have more machinery, your production possibilities could theoretically increase, and you might be able to get yourself a new PPC out to some point like that. And we actually had some, because of capital goods, we had some growth and we got to point C. Alright, that is a kind of a messy graph there. I hope you can make sense of that, maybe draw 3 different graphs in your own notes. The last part here, we are going to, in part 3 of this video, come back for that. We're going to kind of tie a bunch of these graphs all together to explain a scenario.